Looking at the night sky, astronomers of all times have chosen light as their study tool. There is no other source of information about distant stars and the galaxies they form. For the scientific community, the classical wave theory, despite being contested in various ways, continues to govern cosmological behavior. It tells us, for example, that light and sound would behave in the same way, as light would also be formed by continuous waves. Thus, because of its redshift, astronomers use light to measure distances, and, because of its fixed and limited speed, assess the time that separates us from the stars in light years. Being continuous, the waves would allow us to follow them in the direction of our past, using some form of remote tracking. The behavior of cosmic radiation, then called the background, tells us that all the matter in a universe would have been concentrated in a single point in space, smaller than the pinhole of a needle. Now, let's point out some difficulties in this way of approaching the cosmos through the light it makes available to us. As space-time would prove to be homogeneous and isotropic, light would not depend on the direction of its propagation. So, the light could either be stretching from the Big Bang or contracting from the present. It's all a matter of viewpoints. If the light were a straight red, the arrow of time would point to the past and away from us. It is more logical to think that the real propagation direction to be chosen would be from the past to the present. This present, then, would be placed relatively in the future of the singularity. This would not rule out the hypothesis that, contrary to what is supposed, the singularity could be sending its light from our future. These two directions of the arrow of time would be illusory, since for the observer, the past no longer exists, and the future would not have arrived yet. By principle of exclusion of direct access to time, in both cases, the Big Bang would have had its origin in the present of the universe, a two-dimensional plate without time. When you think about the future and the present, you already find yourself looking back in time. It is only from the present that cosmic radiation allows its tracking, thus becoming a background radiation. If the Big Bang did not carry the image of an explosion, which spread radiation through time, it could simply have the nature of an information boom. This information would reach us in the present, coming from distant galaxies. As the future has not yet happened, this earlier shift in radiation cannot be directly assessed. We have to wait for the light to spread along with us, and only then start its remote tracking. It can be concluded that when it comes to our point of view, starlight has always been around. When we study light, we see that it would have a dual nature, but not just a wave or a particle. It would behave in the same way as a spring, attached to a fixed end, performing a simple harmonic movement, composed of two phases. When we measure the distance of the Big Bang in time, putting it 13.7 billion years into the past, we are considering that light would be in its stretch phase, redshifting. It would correspond, in the model of the mass spring assembly, to the first phase of the simple harmonic motion. For physicists, this harmonic behavior of light is also attributed to space, generating confusion. That is, one cannot separate the behavior of space from the behavior of cosmic radiation. Space will bend if light bends, as it is the tool used to measure its geometrical change, the true messenger we trust blindly. Space does not communicate anything to us directly. We know stars exist, thanks to the light they send us. If one of them went out at this moment, space would have nothing to tell us about it. For the theory of general relativity, space and time would complement each other. If space were to stretch, time would contract. Thus, in the case of cosmic radiation, the first phase of its harmonic motion could not have its existence directly confirmed due to the complementary contraction of time. The redshift would be suspended in the void. Thus, the record of the hypothetical displacement of cosmic radiation, starting from the Big Bang, would be cancelled until the moment when the radiation spreads next to us. For all intents and purposes, due to the retention of time, in the inflationary phase, the Big Bang would be placed simultaneously in our future and in our present. Since we need to wait for the instantaneous manifestation of distant events, we would be looking at the present of the universe, as if we were in the past. With the shift from ground zero of time to our position on Earth, the present and the future would merge into the same concept. You would probably go into shock if you could get a sense that the universe continues in the present, while you are the one who would be exiled in the past. Without direct access to light, in the first phase of its harmonic motion, information about future events would have to be available in the second phase. That is, in the space spring contraction phase. When described later by its messenger, space appears to contract continuously, accompanied by time dilation. In this internal phase of spacetime, it is no longer possible to predict that there is anything outside. Physics tells us that the spring would be at rest at infinity, with space starting to contract from there. The elastic potential energy would continuously decay in this phase, as the distance between two bodies decreases. Its continual fall would prevent it from rising at any time. Thus, there would be no scientific support for the existence of an inflationary phase within space-time, as it would necessarily be accompanied by an increase in potential energy.